For an example for mass diagrams on Earthworks. So for instance, we have here, find the volume and extra soil needed. Extra soil needed to be held off-site after the terrain in the given diagram leveled to an elevation of 0 meters. The width of the pile of soil is 10 meters. So ito ngayon yung ating data. The distance or the stationing as shown in feet and elevation. Naka-feet. Bakit naka-feet? Dapat naka-meters yan. So, that's supposed to be meters. Palitan nyo na lang. Supposed to be in meters. Okay? Then, pakipalit na lang yung feet sa meters. Plot natin yan with our diagram. So this will be our diagram on that one. The station versus the elevation. Elevation pa lang kasi hindi pa natin alam yung volume. As you can see, we have here multiple regular polygons or regular shapes. We have triangles, trapezoids, rectangles, and so forth and so on. Not necessarily just the same as the diagram that I've shown kanina, no? Meron naman tayong paggagamitan doon later on. Doon na sa mismong cut and fill requirement. But this time, we'll just have to identify the extra soil needed to be held off. Held off or tatanggalin natin. So ito yung excess, yung sobra. Kasi ang gagawin lang naman daw niya is to cut a specific volume on this fill to be transferred on this section. So basically, ito yung ating cut. And ito yung magiging fill. Okay, ito yung butas. And kukuha tayo ngayon ng soil dito sa section na yan. Then ito transfer daw natin dito. And ano yung magiging sobra? With consideration that they have the same length or width of pile of soil, which is 10 meters. Okay? So by doing so, natin siya sa dalawang solusyon. By the cut and by the fill requirement. First stop, compute natin yung area nito or yung ating fill. Compute yung area ng fill na kailangang i-cut. So, compute natin lahat yung area na yan by dividing it into multiple shapes or multiple regular polygon shapes. Then, area total fill or total cut ba naman yan? Wait lang ha. Now, area of total cut. So, as you compute, there you have your triangle plus the rectangle plus the trapezoid and another rectangle, trapezoid, rectangle, then triangle. So, kayo na mag-compute given naman na yung table at saka yung diagram. So, I'll have a total area of cut which is 280 square meters. Compute natin yan sa volume by multiplying it with its total width of the pile of soil. 280 square meters times 10, we have 2,800 cubic meter. Now, we'll have to compute now the area for the filling section. So, area total of the fill, we have your triangle, rectangle, trapezoid, rectangle, triangle. Or trapezoid na yan, sakali. But you just have to compute it into multiple regular polygons. Then, you have 145 square meters. Total volume, 145 square times 10, basically 1,450 cubic meters. Okay? Then, for us to compute now, the extra soil. Extra soil. So, kailangan na daw nating ihaul yung soil sa cut doon sa ating fill. Ano ngayon yung susobra? Without considering the compacted parameters, hindi naman na niya sinabi na kailangang i-compact at a certain percentage. So, kung ano lang yung nagkasya dito, yun lang yung kukunin natin at yung susobra yung ating i-haul off. No? Basically, subtract natin yung cut with the requirement for the fill. That is 2,800 minus 1,450. So, meron tayong sobrang 1,350 cubic meters. So, kung project yan, yung 1,350 na sobra ay pwede nating ibalik doon sa quarry at pwede nilang ibalik yung excess na binayad natin for the hauling process at saka doon sa soil na binigay nila, no? And makakatipid kayo dyan, no? as long as alam niyo yung mismong requirement ng howling at saka ng embankment. No? Yan lang naman yan. Based on cost. Then multiply mo na lang yan doon sa cost per cubic meter ng ating soil. Then labor, then contingency. You will know more about that pagdating ninyo sa quantity surveying. Second example will be the completely given table below the profile diagram and draw its equivalent mass diagram. Ito, kukompletuhin na natin. With regards naman to the volume, the required fill, the required cut, the adjusted fill, and so forth and so long. Part na yung compaction, and part na rin yung BCY at saka yung CY. Then stationing, then yung cumulative area, cumulative volume. So ito yung ating sample data. Ito based on the field lahat yan. Based on field requirement. So meron tayong stations. Stationing at specific sections. Then convert lang natin yan sa meters as shown. So 100, 200, 325, 425, and so forth and so long. Then end area. Ito yung section. The area requirement for cut and area requirement for fill. Designated as SF. Then the required volume will be computed later on. Then the volume of fill. The strip cut will be in English unit. Ito yung standard unit natin for Earthworks. CCY and CCY. So we'll have to convert that into cubic meters by dividing it by 27. Constant yung 27, binubuo ko na siya para meron akong contingency na more or less 2%. Parang sobra, kumbaga. Then total cut, then total fill, adjusted fill, and the required volume. Ito ngayon yung i-graph natin. Ito yung importante. Dapat tama yung algebraic sum, BCY, then yung ating station. Then, dahil yan yung ating i-graph for our mass diagram using a smooth curve. Hindi na yung regular shape. Now, how do we compute those columns? For the volume of cut, we just have to add end area cut plus end area cut previous. Then, divided by 2. Times station 2 minus station 1, or the required distance from the current station with the previous station. Then all over 27. Over 27 kasi kung convert natin siya into feet. Naka-cubic yards ito eh. Ito naka-meters. So divided by 27. Then end area of fill and end area of fill plus end area of fill previous. End area of fill current plus end area of fill previous over 2 times station 2 minus station 1 over 27. Total cut is volume of the cut minus strip cut. Total fill is volume of the fill plus strip fill. And adjusted fill will be the total fill all over 0.9. Bakit all over 0.9? Kasi i-assume na natin na hindi eksakto yung more or less na mailalagay natin dun sa fill or makukuha natin sa fill para meron tayong excess, no? Lagi tayo dapat may excess. Then algebraic sum is basically the total cut minus adjusted fill. So sa adjusted fill, 90% yung more or less nagagamit, kumbaga, after the compaction. So, assume na natin na nandun na yun. Then, complete the data using the formula. Using your Excel, madali nyo lang gawin yan. So, ito ginamit ko na yung Excel. So, yan na yung data natin all throughout. So, as you can see, positive, negative, positive, negative. So, ang ipa-plot natin dito is station versus the algebraic sum. Using Excel again, you can immediately generate that mass diagram. So, ito ngayon yung ating mass diagram. So, ngayon yung ating mass diagram, which will later on your basis in computing your overhaul and your average haul. No? Your average haul lang naman is the areas over the peak valleys. Compute nyo lang yung volume yan, volume nitong section na to, and kukuha na natin yung average house. So basically, that is your cumulative volume in cubic yards and station in meters. In meters, cubic yards and in meters. Cubic meters and in meters. Yan lang naman po ang mass diagram. And more examples on, search na lang kayo ng iba pang examples and try to practice in some other examples. So that is it. Hindi, meron pa pala. For the calculation of total cost in earthworks, ito lang naman yan. Cost of free howl, basically, free howl per cubic meter times the volume of the free howl. Borrow, cost of borrow per cubic meter times the volume of borrow. Cost of waste, simply cost of waste cubic meter times the volume of waste. Cost of overhaul, cost of free howl per cubic meter, volume of overhaul, times the volume of overhaul plus the cost of free howl per cubic meter station times the volume of overhaul times the average howl distance, free howl distance. Hindi na natin masyadong yan. Nasa estimate nyo na yan eh. Ibigay ko lang yung pahapyaw. Now, this is some example data when it comes to earthworks estimate table. Ito yung example lang naman po. Ito yung dito? Material. Ito yung material section or description section. Ito yung quantity, yung average, at saka yung height. Man-hour per quantity kasi yung data dito based on manpower at saka doon sa requirement. You have your machine excavation, lahat yan kailangan yung isama. Kung kailangan ng howling or ng earthworks sa sand, marl, granular backfill, soil backfill, manual foundation para sa foundation, para sa slab on grade, grading and finishing, roadworks, and so forth and so long. But iba pa po yan. Hindi lang soil ang earthworks natin. Okay? Based on the construction specifications pa yung iba. Saka yung materials pa yan. So that is it for module 15, profile diagrams or mass diagrams. Ang importante muna dito is for you to know how to plot a mass diagram. And the rest will just a simple algebra. Volume and areas na lang yung iba. So if you have any questions, tanong na po, then you may start glancing all the assignments or the requirement for the module 15 on its elaborate and evaluate section.